The race to build a true, thinking, artificial general intelligence is the defining technological quest of our time. And the story we've been told about this race is straightforward. The frontrunners, labs like OpenAI and Google DeepMind, are locked in a sprint, and their strategy seems almost obvious. Build ever larger neural networks, secure billions in funding, and train them on the entire digital archive of human knowledge. The results have been staggering. We witnessed the birth of intelligences that can reason, write, and create in ways that feel impossibly human. The path forward seems clear: bigger models, more data, and eventually the emergence of AGI. This is the conventional wisdom the story experts were sure they knew. But a strange and persistent anomaly has begun to surface. A nagging question whispered in the halls of these very same labs: what if more data isn't the answer? Leaders in the field have started to publicly acknowledge that simply scaling up current methods, the very strategy that has brought us this far, may not be enough to cross the finish line. There is a growing sense that a fundamental piece of the puzzle is missing. This creates a profound strategic mystery. If the frontrunner's path has a potential dead end, is there an alternative route to the next great leap in AI? And could a different kind of industry we've largely overlooked be uniquely positioned to discover it? This isn't just an academic debate. At stake is the trajectory of the most powerful technology humanity has ever conceived. The answer to this question could determine not just who wins the race, but what kind of intelligence we ultimately create. The central anomaly, the observation that doesn't fit the established framework, is a simple but terrifying possibility: that an AI trained only on the internet learns about the world like a person who has memorized an encyclopedia. This brings to mind the famous Mary's Room thought experiment. In it, a brilliant scientist named Mary has lived her entire life in a black and white room. She's learned everything there is to know about the physics and biology of color vision. The question is, if she were to leave the room and see the color red for the first time, would she learn anything new? It seems obvious that she would. The AI knows all the facts, but it has no lived experience. It can describe how to ride a bicycle perfectly, but it has never felt the sting of falling or the thrill of finally finding its balance. The question this raises is profound. Can you truly understand the world if you have never had to act within it? And if the answer is no, then our entire roadmap to AGI might be leading us in the wrong direction. To understand why this anomaly is so disruptive, you first have to appreciate the sheer power and elegance of the prevailing theory. For years, the consensus has been that intelligence is fundamentally a problem of data assimilation. The human brain, after all, learns by absorbing information through the senses. So the thinking went, if we could build a digital brain, a neural network, and feed it a truly colossal amount of information, it too could develop a sophisticated model of the world. A neural network is, at its core, a complex system of interconnected nodes, like digital neurons, that can learn to recognize patterns in data. The bigger the network and the more data you give it, the more intricate the patterns it can learn. This data-centric approach has been the undisputed champion of the AI world. It's the logic that underpins the large language models, or LLMs, that have captured the world's imagination. Think of an LLM as a universal pattern matching machine. By analyzing trillions of words from books, articles, and websites, it learns the statistical relationships between them. It learns that the word queen is often associated with king and palace, and that a sentence starting with "the laws of physics dictate" is likely to be followed by a certain kind of formal scientific language. It is an incredibly powerful form of mimicry, allowing the AI to generate text that is coherent, insightful, and often indistinguishable from that of a human. This strategy is straightforward and, so far, has proven incredibly powerful, attracting immense financial backing. Global AI funding exceeded $100 billion in 2024, with giants like OpenAI and Elon Musk's xAI securing multi-billion-dollar rounds. This isn't just investment, it's a profound statement of belief in this data-centric roadmap. The theory is compelling because it's working. These models are mastering language, beginning to reason, and processing information on a scale we can barely comprehend. We would continue to build bigger digital brains and feed them our ever-expanding digital universe until one day a truly general intelligence would simply emerge. This was the official story, a seemingly irrefutable intellectual structure, but it was built on one critical assumption: that knowledge about the world is the same as intelligence within it. The first thread in the unraveling of the official story wasn't a failure, but an economic paradox. The prevailing theory of AI development is fueled by a specific kind of financial engine: venture capital. AI labs run on massive, multi-billion-dollar injections of capital, all based on the promise of what they might build someday. It's a high-stakes bet on a future breakthrough, a relentless pursuit of a distant, world-changing goal. But as we looked closer, a different economic model appeared to be operating in the shadows, running on a completely different logic. This alternative engine wasn't just a quirky exception, it was a quiet revolution, humming away with a more resilient and persistent power source, suggesting a radically different path to advanced AI had largely been unnoticed. The answer was hiding in plain sight, in an industry that has accidentally been building the most advanced training grounds for artificial intelligence on the planet: video games. The gaming industry, by contrast to the venture capital model, has a sustainable, self-funding AI development loop. A marginal improvement in the AI that controls the cars and pedestrians in a game like Grand Theft Auto isn't a theoretical step towards AGI, it's a feature that makes the world feel more alive, translating directly into millions of dollars in sales. This creates an immediate and predictable return on investment, a powerful, continuous loop where profit from today's AI directly funds the development of tomorrow's AI. Between 2020 and 2024, investments in the picks and shovels of gaming, the essential tools and infrastructure, saw a seismic shift, with AI-focused startups surging from just 4% of that investment to a dominant 65%. This self-funding cycle does more than just make better games. It has been unwittingly constructing the most sophisticated laboratories for intelligence ever conceived. These are not just interactive worlds, but digital petri dishes where a new form of AI can be born and raised. This is the dawn of the agentic AI. Forget the passive chatbot waiting for a prompt. Imagine instead an intelligence with true agency. You can unleash it into one of these complex virtual realms with a high-level goal: outmaneuver a rival empire, master a fictional economy, solve a planetary mystery, and it will independently strategize, act, and learn within that dynamic world. It doesn't learn by reading a description of a strategy. It learns by formulating one, executing it, suffering the brutal consequences of failure, and trying again. This is the crucial leap from abstract knowledge to applied wisdom, from memorization to genuine experience. Yet to render these millions of intricate laboratories in breathtaking detail required a computational revolution of its own. And here lies the most elegant twist in this story: the multi-billion-dollar research and development crusade that unlocked the awesome parallel processing power of the GPU wasn't initially bankrolled by the lofty pursuit of artificial intelligence. For decades, it was funded by the far more visceral, insatiable demand of gamers for more realistic graphics and fluid frame rates. The entire AI industry now stands upon a hardware foundation paid for and relentlessly advanced by the world of entertainment. This has ignited a powerful flywheel. The consumer gaming market continues to drive the frontier of hardware, software, and as a magnificent byproduct, it forges an ever more powerful foundation upon which the world's most advanced artificial minds are now being built. With this astonishing hardware flywheel now spinning at full force, a second, stranger convergence began to accelerate, not in silicon, but in software. On one side, you had the titans of AI research like Google, architecting what they call world models. AI systems designed to comprehend our reality by generating their own interactive 3D simulations from a single image. On the other, you have the sprawling universes of gaming, with platforms like Roblox releasing open-source AI tools that empower any user to conjure complex worlds and objects simply by describing them. Two industries, starting from opposite poles, one seeking to train an artificial mind, the other to entertain a human one, were now converging on the exact same technological frontier: the instantaneous creation of simulated, interactive realities. The journey so far had left us with a series of powerful, disconnected pieces: a strange, self-funding economic engine humming in the background, the existence of almost impossibly perfect virtual laboratories, a secret history of hardware that felt like a hidden origin story, and that odd convergence of goals from completely different fields. They were just loose ends, fascinating but separate. The key that unlocked the entire mystery the instant the entire picture snapped into focus was a fundamental shift in perspective. It was the realization that we may have been asking the wrong question all along. The race wasn't a single sprint to one finish line called AGI. It was in fact a two-stage journey. The first stage is the one we've all been watching. It's the race to build a massive, knowledge-based intelligence, the Encyclopedia AGI. This race is OpenAI and its peers are winning. Their data-centric approach is perfectly suited for creating an AI that has assimilated all of human knowledge and can reason about it with incredible speed and accuracy. This AI will be profoundly powerful and will change the world. But it is only stage one. The paradigm shift, the dramatic turning point, is the revelation of stage two. The next, more profound leap is not from knowledge to more knowledge, but from knowing to doing. The leap is towards an agentic superintelligence. An AI that can not only process the world, but can act within it to achieve goals. And this higher form of intelligence requires more than knowledge. It requires experience. The single critical insight is this: the missing piece isn't more passive data to learn from, but a better environment for active learning in. This new explanation completely reframes the entire problem. The gaming industry is no longer a niche market applying AI for better graphics or smarter characters. It is the world's leading developer of the very thing needed for stage two: rich, interactive, goal-oriented environments. For over 40 years, in their relentless commercial pursuit of immersion, game studios have accidentally become the world's foremost experts in building worlds. They have created a vast and diverse library of sandboxes where an AI can learn to navigate 3D space, manage complex systems, cooperate with others, and formulate long-term strategies, all while receiving immediate feedback on its actions. They have, without intending to, built the perfect crucible for forging an intelligence that learns by doing. The conventional wisdom assumed the path to AGI was a library. The revelation is that it might actually be a playground. With this new understanding, all of the clues from our journey suddenly click into place with satisfying clarity. The economic paradox is resolved. The gaming industry's self-funding engine is so powerful precisely because it's not selling a far-off promise of AGI. It's selling increasingly sophisticated training grounds for AI. and a marginal improvement in those training grounds has immediate commercial value. Games are not just a test bed for AI, they are potentially the ultimate environment for its development. And that strange convergence of AI labs and game companies building worlds, it's the clearest signal of all that both are converging on the same fundamental truth, that the future of AI is inextricably linked to the creation of simulated realities. The implications of this paradigm shift are profound. The key to the next great leap in intelligence might not be held by a researcher with the largest data set, but by a game designer with the most compelling world and game mechanics. It opens up new lines of inquiry. What if the most important AI company of the next decade isn't named OpenAI or Google, but Epic Games or Roblox? What happens when you combine the world-building expertise of a game studio with the explicit AGI ambitions of a company like Elon Musk's xAI, which has already announced its own AI-powered gaming initiative? This reveals something fundamental about innovation itself. It reminds us that the most revolutionary technologies often emerge from unexpected places, born from industries pursuing entirely different goals. The current AI revolution is a prime example of this, having unexpectedly emerged from the simple concept of predicting the next word in a sentence. This seemingly modest task, when scaled with massive amounts of data and computing power, has led to large language models with emergent abilities, unforeseen capabilities like reasoning, translation, and code generation that were not explicitly programmed into them. The relentless pursuit of what was essentially a statistical language challenge has inadvertently created a powerful engine for the development of intelligence itself. Perhaps the more powerful path is not to create an intelligence that has read all of our stories, but to create one that is capable of making its own. The true leap forward isn't in knowing all the pieces, but in understanding how to play the board. Being a reader might be sufficient to create an artificial general intelligence, but we can't be certain. However, what we are sure of is that super intelligent AI must be a gamer,